Hello, this video will provide the mathematics behind the Edgeworth box. We're going to have an exchange economy with two consumers, consumer 1 and consumer 2. We're going to have two goods in this exchange economy, good X and good Y. Consumer 1's utility function is given by the following: 10 times the natural log of good X plus the natural log of good Y, and consumer 2's utility function is likewise defined here. Consumer 1 has initial endowment of 55 units of good X and 0 units of good Y. Consumer 2 has an initial endowment of 0 units of good X but 110 units of good Y. The subscripts just represent consumer 1 or consumer 2. So what we're going to try to find here is the equilibrium, the Walrasian equilibrium. So we're going to start this way. We're going to first start by constructing the constraint, the budget constraint. The budget constraint for consumer 1, well, let me just write the budget constraint in general format. I is income. We got the price of good X times units of good X for consumer 1 plus the price of good Y times units of good Y for consumer 1. So consumer 1 has 55 units of good X. So consumer 1's maximum income is those 55 units times the price of good X, what the consumer could sell those units for. That would be the consumer's maximum income. And I'm just going to rewrite everything this way. Oops, let me put a 1 on the Y here, one subscript on the Y. And one thing I'm going to do here, I'm going to divide everything through by PY, by the price of good Y. You'll see why in a minute. What's next? So I divided this top expression right here through by the price of good Y. Now let's let the price of good X divided by the price of good Y just equal to P. Okay, we're going to simplify that. So if we do that, then let me go onto a clean screen. If we do that, we're going to get 55P equals P times good X plus good Y. This is consumer 1's budget constraint. Let's do the same thing for consumer 2. Consumer 2's budget constraint. I'll go over here. So this is consumer 2, and this is consumer 2's budget constraint, or just constraint for short. So from consumer 2's perspective, the consumer's income, I, can be written like this. This consumer has 110 units of good Y. So from the previous slide, we said the initial endowment for consumer 2 was 110 units. So that's upper level limit on consumer 2's income. Consumer has 110 units of good Y. It could sell those units at PY, raising this amount of income. And then we just rewrite. And let's do what we did before. Let's divide through, but this time let's divide through by the price of good X. And since we defined the price of good X divided by the price of good Y as P, we just got 1 over P. here. And we now have Consumer 2's budget constraint. Okay, so Consumer 2's budget constraint and Consumer 1's budget constraint. So that's the first thing I like to do in these type of problems. The next thing I want to do is maximize utility for Consumer 1. Let me start on a clean slide. So for Consumer 1, we're going to maximize utility. Maximize U. So what I'm going to do is I'm going to get the marginal utilities of good X and good Y for Consumer 1. We're going to take the derivative or partial derivative of Consumer 1's utility function with respect to x1. And we're going to get this result. And as I said, this is the marginal utility of good X. And we're going to do the same thing for good Y. We're going to take the marginal utility. To get the marginal utility of good Y, we're going to take the partial derivative of the utility function with respect to good Y. And if you do that, you just get 1 over Y. That is the marginal utility for good Y for the consumer. When the consumer is maximizing utility, this condition must hold. This optimizing condition must hold. The marginal utility per dollar spent on good X equals the marginal utility per dollar spent on good Y. All I'm going to do now is substitute in our marginal utility expressions into this formula. Okay, so 1 divided by good Y, that's falling in over here. 10 divided by good X, that's over here. And now we just want to simplify this a little bit more. Go up here. Left something like that. Okay, so just all I did here was multiply the denominator and numerator by 1 over the price of good X, and then I did a similar thing over here. Or multiplied the denominator and numerator by 1 over the price of good Y. And you're left with this expression. From here, let's solve for good Y. And if you do that, we're left with this. Dividing through by 10. And then recognizing what we said before, the price of good X divided by the price of good Y is just P. So we have this expression. Okay. The next thing we're going to do, and maybe we should do that on a clean sheet. Let me rewrite what we just got before. We're going to take this result and we're going to plug it into the constraint, the budget constraint. So we're going to plug this guy into the constraint. Let me rewrite our constraint from before. So this is y1. So where we ever see the y1, y subscript 1, we're going to plug that in. And now we're going to solve for the demand for good X. Okay, so the right-hand side will simplify to something like this. Notice that the p's cancel. Okay, multiplying through by 10 divided by 11, we're going to get 50. So x1 equals 50. And now we can say something about x2. How many units of good X does the second consumer consume? Well, given that we had an endowment, a total endowment in this exchange economy of 55 units of good X, consumer 2 will only be able to consume 5 units. We said consumer 1 is consuming 50, so consumer 2 will be left with 5. Okay, so that's kind of neat. Another thing we could do here is we could take this 50 and we could plug it back in either to the constraint or this function over here. Let me plug it in here. We're going to get y1 equals p times 50 over 10. And we got consumer 1's demand for good 1. Remember, p is the price of good X divided by the price of good Y. So indeed, if the price of good Y went up, the consumer would buy less good Y. All right, let's move on now to consumer 2. We're going to maximize utility for consumer 2. I'm going to maximize utility for consumer 2. We're going to do the same thing, get the respective marginal utilities. Taking the partial derivative of our utility function for consumer 2 with respect to good X, we get this. Marginal utility of good Y. We get 10 divided by good Y for consumer 2. As before, we set up the optimizing condition. Plug in our marginal utilities in this expression, and then we're going to simplify. Okay, so simplifying like we did before. We'll be left with this result. All right, let's solve this for good X. Okay, we'll solve this guy for good X. And if we do that, we'll get something like this. Okay. So I multiplied through by X, and then I multiplied through by price of good Y and Y2. So that's also thrown over here. Okay, and you'll get this result. Simplifying. you have that result. And now we're going to plug this into constraint. So we're going to plug this into the budget constraint. So the original budget constraint for consumer 2 was something like this. Let me rewrite it to remind you. That's a 2, sorry. And then we simplified it down to something like this. Okay. And so from our last screen, we had good x equals good y divided by 10 times p. I'm going to go ahead and plug that result now into here. Don't forget the 10. Adding up the right-hand side. The p's are going to cancel. 2. You're going to get good y equals 110 times 10 divided by 11, or 100. So we have 110 units of good y in total. Consumer 2 will consume or take 100 of them. That means consumer 1 will be left with only 10. Okay. One other thing we could do here we could take this 100, okay, and we could plug it back into this expression over here for x2. And we're left with 10 over p. So let me write that up too. Okay. All right, let me go now to a clean page and sum some of these things up here. Okay, so what we found so far was that consumer 1 will consume 50 units of good X, consumer 2, 5. We found that consumer 2 will consume 100 units of good Y, consumer 1 only 110 units. I'm sorry, only 10 units. And we also found that x2 equals 10 divided by p, the demand for x2 for consumer 2. And for consumer 1, we found that y1 equals 5 times p. I'm doing this because now we can solve for the equilibrium price. So for example, the demand from consumer 1 plus the demand from consumer 2 for good Y has to equal 110. We started this problem with 110 endowment for good Y. So what is Y1? Well, for consumer 1 it's 5p. What is it for consumer 2? 100. So solving this problem, P equals 2. Or Px divided by Py, the relative price of good X to good Y, is 2. So we get the equilibrium price here. We could have also found this by doing a similar idea for good X. The total demand for good X, consumer 1's demand and consumer 2's demand, has to equal our total endowment in this economy, 55 units of good X. So X1 is 50. What is X2? Well, let's use this expression with the P in it so we can solve for P. And now we can solve this problem. And here again, P is going to equal 2. So that's how you solve one of these exchange problems with two consumers and two goods. I hope you found this beneficial.